Okay, this is the next FRQ. We're going to be talking about comparing z-scores and why, and then this is in chapter 2. Okay, so I don't really remember doing this FRQ, but I'm going to assume that it's just, since it said that we're finding the z-score and comparing, I'm going to use this one as an example. So it says National Test A has a normal distribution with a mean of 500 and a standard deviation of 100. While National Test B has a normal distribution with a mean of 18 and a standard deviation of 6. A student scored a 677 on Test A and 29 on Test B. Relative to the respective distributions, which score is better? Okay, so when you see this, you should be underlining the important stuff. Okay, so there's two tests, right? They were scored differently. So the first thing that I look at when I see this is normal distribution. So when I went to go get help with Miss Power, she said whenever you see normal distribution, you're going to want to draw a normal curve, which is the curve. This is going to be your mean. Right here, you're going to write your mean. And then you're going to write n, and then in parentheses, you're going to write your mean and your standard deviation. Okay, so that's what I did for the first one. So we're going to look at test A, right? So it said that test A has a normal distribution. I drew it over here. So I drew this to kind of get a visual. So I put the mean right here, 500, and it says that the student scored 677. This is test A. So I just put a line on where they scored. And then again, this is the n, and then in parentheses, your mean and your standard deviation. So first we're going to look at test A, right? So the formula to find a z-score is z equals x minus mean over standard deviation. You need to memorize this. So for test A, it tells you that the mean is 500 and their standard deviation is 100, and the student scored 677, right? So we're going to do this, right? So this is going to be for your z. So we're going to say z equals your x, which is the value that they gave you. So the student scored 677 minus your mean, 500, all over your standard deviation, which is 100. And if you put that in the calculator, it's going to give you 1.77. So that's the student z-score for test A. Now for test B, it's going to be the same thing. It tells you that the mean is 18, the standard deviation is 6, and that the student scored 29, right? So you're going to do the same thing. You're going to do x, which is 29, minus mean, which is 18, and then over standard deviation, which is 6. And then if you calculate it, it's 1.83. So in the problem, it told you it's asking you which score is better. So now that you have the z-scores, you can compare them. So since this one is bigger, that means that they scored better on this one. So if you were to explain it in an FRQ, I would probably write that the score of 29 on test B is better, and that test B had a z-score of 1.83 and test A had a z-score of 1.77. Since test B's z-score was higher, it makes that score better. Okay, and I don't know what other questions it could ask you, but I was looking at the packet, and so it tells you how to explain it, right? Z-scores show the position relative to the other values in the distribution. So so remember that we drew the normal distribution curve for here. Okay, so this is the average score. This is what the student got. So they scored higher than the other person, right? Than the average class, right? But this student did too, right? So we were trying to figure out which one is better because it had different grading scales. Okay, so if it gave you a different problem, let's say number 2, right? So it says calculate and interpret the z-score for Utah. So it says below is a dot plot and summary statistics for the number of public colleges available in each of the 50 states. Okay, so this one says Utah has 17 public colleges. Calculate and interpret the percentile for Utah. Okay, so remember for percentile, this is how we're going to do it. So it says Utah has 17 public colleges. Calculate and interpret the percentile for Utah. So it tells us that Utah is over here. If you count all these dots, this one is going to be the 14th dot. So you're going to put that one on top. And then there's 50 states. So you're going to put it over 50, and then you get 0.28. So that's going to be 28% of states have 17 or fewer public colleges. Okay, so that's how you calculate and interpret that. Now that you have that, you can do the z-score, which is your x, which we figured out was 17, minus 39.24, because it tells you right here, the mean, over your standard deviation, 32.844, and we get negative 0.677. Okay, so now we have to explain it in context. So I wrote the number of public colleges in Utah is 0.677 standard deviations below the mean score of 39.24. So remember, I told you guys that in the graph, you're writing the normal, and then you write the mean and the standard deviation, right? And over here, this is where you write the mean, and when the mean was 39.24. And so what this is basically saying is that their z-score was lower, right? So it's 0.677 standard deviations away from the mean. So that's what it's basically saying. And then remember, I guess standardized score is the z-score. So we said this is the formula, right? So for this one, it already gave you the z-score, so we're going to plug that in here. So it's 0.267. Okay, so now we're going to make that equal to x. So it doesn't tell us what x is, it just tells us how many public colleges does Michigan have, which is your x, your value that you're trying to find, right? And then you're going to subtract it from the mean. We know the mean, right? And then you're going to put it over your standard deviation, which is this number. And so now you're trying to find x, right? So you're just going to multiply this. You're going to cancel this out. You're going to multiply this, multiply both sides. And then you're going to get x by itself, and then you're going to get 48 public colleges. So that's how you do that. Just remember that you have to interpret it with context, and you have to know what standard deviation means. It means that it's like how far away is like the score or whatever from the average. That's what it means. I don't really know what might be on the FRQ for questions, but just try to remember the z-score, how to explain it, and normal distribution and percentile. You just have to know those things, I think, and then you can probably figure out the rest.